Okay, last one. So this is going to be limiting reactants. And so limiting reactants problems deals with when you have a chemical reaction, what happens if you have some leftover stuff. So when you actually go in the lab and do this, say you don't use your stoichiometry and you don't use an exact one-to-one amount on a mole ratio, whatever your balanced equation is asking for. You'd have some of it left over. So the amount that's left over is known as your excess reactant. So more than the amount needed to react completely is present. Okay, determine the limiting reactant, find the amount of product produced by both reactants. The reactant that produces the least amount of products is your limiting reactant and will determine the extent to which the chemical reaction takes place. So that's one way to do it. There's other ways to do it as well, but I think this is the easiest. Just use each reactant that you have, see which one produces the least amount. Whichever produces the least amount is your limiting reactant, and that's how much product you make. The other one will be in excess. So let's go back and apply this to cheesecakes. So remember my equation. 3 blocks of cream cheese, 1 cup of sugar, and 5 eggs made a cheesecake. And so I want to know how many cheesecakes can I make. I go in my kitchen and look what all I have. Okay, I notice I have 6 blocks of cream cheese, I have 10 cups of sugar, and 25 eggs. So I know how much I can make. And so using my balanced equation, I'm not going to calculate all these out. We're just going to go ahead and do these in our head. So 6 blocks of cream cheese, I know it takes 3 blocks of cream cheese to make 1. So if I have 6, that means I can make 2 from the 6 blocks of cream cheese. Takes 1 cup of sugar, I have 10 cups. So from that, if you make 10, 25 eggs, I know it takes 5 eggs to make 1. So 25 divided by 5, I can make 5 cheesecakes from that. And so which one produces the least amount? That would be the blocks of cream cheese. So I'm limited by how much cream cheese I have. So cream cheese is my limiting reactant. And I could also calculate how much excess I would have. So if I made 2 cheesecakes in, how many cups of sugar would I have left over? Well, I know to make 2 cheesecakes it takes 2 cups of sugar. I have 10, so 10 subtract 2, I have 8 cups of sugar left over. How many eggs would I have left over? Well, I'm making 2 cheesecakes, it takes 5, so to make 2 it takes 10 eggs. I have 25, so I have 15 eggs left over. So we can do this with chemistry as well. This just goes in and relates it to cars and tires. So I have 8, and I'm looking at adding tires to all 8 cars. So I know 8 times 4 tires would fit on one car. So 8 times 4 would be 32. And so 48 subtract 32, then I have 16 tires left over. Here's another example of limiting reactants. So let's look at a more difficult chemistry problem now. 55 grams of nitrogen gas is placed in a reaction container with 55 grams of hydrogen gas. Determine which chemical is the limiting reactant and the number of grams of ammonia gas that can be produced by this reaction. Okay, let's do that first. Then I want to find the percent yield of 55 grams of ammonia obtained. First thing I need to do is balance the equation. So 6, 3, 2, 2, okay, so it's balanced. So first thing I'm going to do is see how much ammonia can be produced by 55 grams of nitrogen. Again, on your homework simulation for the requirement, you're given moles, so you can skip this conversion moles, you already have moles. So nitrogen, look at the periodic table. It's 14.01, I'm going to say. So I have 2 of them, so that would be 28.02. So now I have moles, I can use my balanced equation. 1 mole of nitrogen produces moles of NH3. Use the molar mass of NH3, so 14.01 plus 3 times 1.008, so 17.03. So that's how many grams of ammonia would be produced. 55 times 2 times 17.03 divided by what's on bottom, so 28.02. I get 66.86, so 66.9. So that's if all 55 grams of nitrogen reacted, that's how much ammonia would be produced. Do the same thing for hydrogen. Here I have 2 times 1.08, so 2.016. So it takes 3 moles of hydrogen to produce 2 moles of NH3. So these ratios just come from my balanced equation. You go from one reagent to another reagent, I have to use the balanced equation. And I can use my molar mass there. So 55 times 2 times 17.03 divided by 2.016 divided by 3. So I get 309.7. So what produced the least amount? The nitrogen, so excess of hydrogen. So my nitrogen must be my limiting reagent. So I answered that question, determine which chemical is the limiting reagent, and the number of grams of ammonia gas that can be produced. So I calculate that out. Determine the percent yield of the reaction if 55 grams of ammonia are obtained. And so my percent yield then would be 55 grams is my actual yield, what I actually got. Theoretically possible is 66.9 times 100. So I get 82.2% for my percent yield. Let's look at one more problem. It says boron sulfide reacts violently with water to form dissolved boric acid and hydrogen sulfide gas. Assume that 5.99 grams of boron sulfide is mixed with 7.85 grams of water. So which reactant is limiting and which is in excess? First thing I need to do is write my balanced equation. So I'm given that this reaction with water, yield dissolved boric acid and hydrogen sulfide gas. Assume that 5.99 grams of B2S3, okay, so I'm going to come forward and see how much of each one that I'd have here. So let's go up here and do this. So got 5.99 grams of B2S3. Well, may just work it down here. See that? Okay. So 5.99 grams of B2S3. Okay, so I need the molar mass of B2S3. So I look at boron and sulfur. So boron's 10.811. Sulfur is 32.06. So you got 117.8 grams per mole, so I'll put that here. I need to go to my balanced equation. Now I forgot to balance this, so I need to make sure this is balanced, okay, before I can use the mole ratio for my balanced equation. So I have 2 borons, I'm going to put 2 borons, 3 sulfurs, and put 3 sulfurs. So that gives me 6 oxygens, so I need 3 here to give me 6, or 6 oxygens, so I need a 6 here to give me 6 oxygens. So that gives me 12 hydrogens here. I have 6 plus 6, 12 hydrogens. So it's balanced. So now my balanced equation, 1 mole B2S3. And I'm looking, see how many grams of boric acid are produced. So that's why I want to go to. So 1 mole of B2S3 makes 2 moles of boric acid. So 61.84 grams per mole. So I need moles on bottom here. So I get 6.29. So that's if the 5.99 grams of B2S3 react completely. So I need to do the same thing with water now. Use balanced equation, 6 moles of H2O produces 2 moles of my boric acid. Again, molar mass to convert to moles, balanced equation to go from one compound to another compound. Then again, molar mass to go from bound to the other. So you get 8.99 grams of boric acid. So since my B2S3 produced the least amount, that's my limiting reagent. How many grams of boric acid are produced then? 0.29 grams. Now, how many grams of excess reactant are left over? So to figure that out, I need to know how much reactant to begin with. And so, again, I'm going to take my limiting reactant, my B2S3, so 5.99 grams. Again, I need to go to my balanced equation to go from one to the other. So to do that, I need this in moles. So use this molar mass again. Now this time I want to know how many moles of water. I'm not looking at how many moles of product. I want to know how much water reacts with that. So 1 mole of B2S3 reacts with 6 moles of H2O. And I use my molar mass of my water to convert to grams. So I put moles on bottom here to get moles on top here to cancel. Here I had moles on top, so my grams would cancel. So that's how much water would be required to completely react with that 5.99 grams. You get 5.49. So that's how much is required to completely react with it. So this is how many grams are left over. Okay. Well, if I look at my equation, I start with 7.85 grams. Okay. Get 5.49 grams of reacted, which is what was needed to completely react. Then I just take the difference, and that'll tell me how much is left over. So 2.36 grams of water are left over. So that's it for limiting reactants. If you have any more questions or if you want me to work some more problems, let me know. But for now, that's it. Bye.